1.4 is a little bit of a continuation of 1.3, and so I think a lot of us felt a little more comfortable with 1.3, so hopefully we'll feel good moving into 1.4. We're going to start off talking about operations with functions and then move into composite functions. So when we're looking at operations with functions, we're just talking about adding, subtracting, multiplying, and dividing. So essentially, bless you, all we're doing is adding, subtracting, multiplying, and dividing polynomials. Okay, so the notation for our addition is this f plus g of x, but all this means is I'm going to take my function f of x and add it to g of x. Yeah. Add the two functions, meaning we're just going to combine them. With the subtraction notation, that f minus g of x, well, so now this just means I'm going to do f of x minus g of x. When you see that multiplication notation, that f times g of x, again, all that means is I'm just going to multiply the two functions together. So it's basically going to be multiplying polynomials. And then last but not least, we have division. So f divided by g of x. So now this just means I'm going to do f of x divided by g of x. In this section, you're also going to be asked about the domain of these new functions that you create. And the domain of the new function consists of all real numbers that are common to the domains of f and g. Now, we need to be careful with a couple scenarios. And one of those is in the case of the quotient function, because our domain is going to be a little bit further restricted to exclude the values in which g of x equals 0. What that means is with quotient, that's when we divide. And so if we're doing f of x divided by g of x, this denominator cannot equal 0. So there will be a value in the domain that will not be possible. Because if it were part of the domain, then our denominator would be equal to 0, and you can't divide something by nothing. So we'll have to figure out a little bit further restriction when we do division. The other time that you'll see a restriction, which I want you to write in here because I don't have an example of it actually on the notes. But if you have like the square root of x, so if you have a square root function, this is going to have a further restriction too, because I can't just plug in all real numbers for x, because underneath a radical, what can x not be? A negative. We can't take the square root of a negative number. So the domain, when we have a square root function, that domain would be for all x's that are greater than or equal to 0. Because you can have 0 under a radical, and you can have positive numbers, but you can't have negative. Other than really those two restrictions, those might be the only ones you really see. Other than that, if you're asked for the domain, it's going to be all real numbers, because there's not going to be any limits or limitations on the functions that are created when we do these combos. Okay? And I'll show you kind of what I mean in these first four. So these first four, we're going to practice these operations. I've got one example of each, so hopefully that will be helpful. We've got f of x is equal to x squared plus x, and g of x is equal to 3x minus 1. We're going to find the new function and then state its domain. So the first thing we're going to do with those functions is add them, because that f plus g of x just means f of x plus g of x. So my f of x function is x squared plus x, and then I'm adding that to my g of x function, which is 3x minus 1. So when we're adding these two functions, really all we're doing is adding polynomials. We're just combining like terms. So there's no other x squares to combine that with, so we're going to get x squared. We do have these like terms with the 1x and the 3x, so now that is plus 4x, and then I can just bring down the minus 1. So there is your new function that you found by adding f of x and g of x. And when we talk about the domain of that, there are no limits as to what I could plug in for x. I can plug in negative 28, 1/2, negative 1,850, positive 1,800. I can plug in any value for x and find an output. So that would be why our domain for something like that or a function like that is just going to be all real numbers. All right. Number 2, similar, except now we're going to practice subtracting the functions. So f minus g of x, again, means f of x minus g of x. So x squared plus x is f of x. X squared plus x. And then we're going to subtract, this time, g of x, which is our 3x minus 1. Now, when we subtract polynomials like this, I would caution you to be very careful, and I would caution you to go ahead and distribute this negative sign and rewrite it without those parentheses so that you don't mess it up. So I would rewrite this as the x squared plus x, distribute the negative, so negative 1 times 3x makes that a negative 3x, and then the negative 1 times negative 1 makes that plus 1. And then we can combine the like terms that we have in the middle. Because again, essentially when we're subtracting these, we're just subtracting the polynomials. So if we combine the 1x and the negative 3x, our new function is, not with the highlighter pen, x squared minus the 2x plus 1. Because 1 minus the 3 is how I get the negative 2x. And again, we just created a quadratic where there's no limits as to what I can or cannot plug in. So all real numbers would be your domain. All right, and then practicing our multiplication. We've got f times g of x. So this just means I'm going to take f of x and I'm going to multiply it by g of x. So x squared plus x, and I'm going to multiply that by the 3x minus 1. And we've got a binomial times a binomial, so I would just use the FOIL method if you would like to draw a box or whatever else you would like to do. But I would multiply the 3x and the negative 1 by the x squared, and then come back and multiply the x to each of those terms as well. Remember when you're multiplying these powers that we add the exponents. So x squared times 3x is 3x to the third power. And then the x squared times negative 1 makes this negative x squared. X times 3x makes this plus 3x squared. And then the x times the negative 1 makes it negative 1x. After we multiplied those, we do have those two like terms that we could simplify. So we would get 3x to the third power plus 2x squared minus x. The negative 1 plus the 3 would give me 2, so I have 2x squared and then minus the x. Again, I can plug anything I want in here for x. There's no denominator that's going to mess me up. There's no radical that's going to mess me up, so it's just all real numbers. Okay? Last one, division, which will be the quickest because we don't need to worry about doing any of that simplifying. F divided by g of x. So again, this notation just means f of x divided by g of x. So this would be x squared plus x, and we're going to divide that by the 3x minus 1. And that's going to be your new function. Even if we were to factor out the x in the numerator, we still couldn't actually simplify any of that. So there is our new function. We can just leave it. Here's where now all of a sudden our domain is not all real numbers. It's all real numbers except one thing. And it's whatever makes this denominator 0, because you can't have 0 in the denominator. So to figure that out, just set it equal to 0. 3x minus 1 is equal to 0. And that will allow you to determine what's that value of x that can't be part of our domain. So then the math here is pretty simple. Move that 1 over, so they have 3x is equal to 1. Divide by 3, that means x cannot equal 1/3. Because if I plug 1/3 into the denominator, now it equals 0, and we'd get an error in our calculator because you can't divide something by nothing. So for your domain, this is going to be all real numbers except that x cannot equal 1/3. So every value except 1/3 could be a part of that domain. All right. The next two, I'm going to have you kind of try with your partner. My last class, I showed up number 5 to make sure everybody was on the right track, and then they kind of gave them a little more time for number 6. But with these, you're going to get to practice using your function operations. Number 5 is an addition problem. Number 6 is a subtraction problem. And then once you've created this h of x, we're going to pull in what we did with 1.3, and you're going to evaluate h of 3. But first, you have to find h of x. And you're going to find h of x by adding the functions. So to find h of x, I'm going to do f of x plus g of x. That's how I'm going to find h of x. Once you find h of x, then you'll evaluate it. Okay? So I'll give you about 2 minutes, and we'll see how you're doing on number 5, and then maybe 2 more minutes for 6, and we'll check back in. Okay. I want y'all to check and see how are you doing so far on number 5. So when you created h of x, so here's where I created h of x, and I created h of x by adding my f of x plus g of x. So you're just adding those polynomials, you're combining those like terms. And then once I did find h of x, this 3 is just what I'm plugging into the function for x to find its value. So h of 3 is equal to 7. All right, I heard a lot of good things when I showed that up. So now we're going to move on to 6. I know a lot of you have already started on 6. Everybody else, you're moving on to 6. This time we're subtracting those functions. So for you to find h of x, you need to do f of x minus g of x. And again, be careful with that minus sign. Make sure you're distributing that. Yes? Oh. All right. All right, so I'll give you guys about 2 minutes. I see some right answers already, so that's good.
Is this like our whole unit or what else?
Okay, h of 0 is equal to 1. So when you subtract the two functions, I love how this happens, but when you subtract, this is where I said be careful, make sure you distribute that negative, so that then when you combine your like terms, you have the 2x minus x, which is 1x, and then negative 5 plus 6, which is 1. So once you have h of x, then you're just going to plug in 0 for x, and you get 1. All right, so we're going to quickly do 2 more here. Because now we're going to look at composite functions. So the composition of functions f and g is given by this f of g of x, which can be rewritten as f of g of x. So what's going to happen with these compositions is we're going to be taking one of our functions and plugging it into another. And whatever's on the inside of the parentheses, that's what we're plugging in. Okay? There's too many parentheses. Is that what you said? This g of x is on the inside of these parentheses, though. So this g of x is the input that's going to get plugged into f. All right? So let's try to quickly get through these. 6 and 7. Oh, just kidding. 7 and 8. Is it as funny as 6 and 7? No? Okay. You've got our f of x function is 2x plus 5, and our g of x function is 4x squared minus 1. So if we're doing f of g of x, again, if I rewrite this, this is f of g of x, which means g of x is our input. And that's what we're plugging into f. Everybody's like, kind of remember this? Yes? So when we plug g of x, this is g of x. You're plugging this into x in the other function. So f of g of x would be 2, but now you're going to plug in g of x. So like in 1.3, we were plugging in just like 3 or 5 or whatever. Now we're plugging in a whole function. Easy. So 2 times 4x squared minus 1, and then plus 5, because that's the rest of this function. This took longer than my other classes. So we distribute this, and this becomes 8x squared minus 2 plus 5. Combine these like terms. F of g of x is 8x squared plus 3. I heard someone say 8, like they weren't sure how I got that. Do you know how I got that now?
This is a weird stuff. Isn't it going to turn into G O F?
Yeah, so next,
This makes me want to throw up.
we're going to do it the other way around.
I just want to just die. Yeah.
But, okay, so now looking at number 8, we're going to do the opposite of that, where we're going to do g of f of x, which means g of f of x. So this time, we're going to be taking our f of x function, which is the 2x plus 5, and plugging it in to the g of x. Because remember, whatever is in here on the inside, this f of x, this one is going to be our input. And so if this is our input, obviously we're going to be plugging it into the other. So we're going to be plugging in f of x into g. So this would be g of f of x is going to be equal to 4 times, because we're going to plug in the 2x plus 5 squared, and then minus the 1. And so just like with 1.3, now that we've plugged it in, we're going to go ahead and simplify this right side of the equal sign. So we're going to start with squaring that binomial. So 4 times the 2x plus 5 times 2x plus 5, and then minus 1. And then there's a couple things we could do next here, but we'll go ahead and multiply these two binomials. So again, using this FOIL method. So we'd bring down the 4. When we multiply 2x by 2x, that's going to give us 4x squared. And then 2x times 5 would be plus 10x. Then come over here, plus 10x. And then that 5 times 5 is plus 25. Now I can combine these like terms. So this is 4 times 4x squared plus 20x plus 25, and then we still have that minus 1. So now that I've multiplied the binomials and simplified that, now I can go ahead and distribute this 4 to the trinomial that was created here. So the 4 times 4x would be 16x squared plus 80x, and then 4 times 25 would be 100, and then finally, minus 1. So our new function here, or our combo, is g of f of x is equal to 16x squared plus the 80x plus 99. And then the domain here would be all real numbers. Because again, there's no limitations or anything that we could plug in to there. All right, so that is part 1 of notes.